So in maths, if points are collinear, this means that you can draw a straight line through these points and only one line. So for example, if I take this point and this point, then these 2 points are collinear because I can draw a straight line. But that's a fairly obvious statement. When we come into higher, what we're not really talking about is 2 points. We're more interested in if we have 3 points. So for example, if I have this point here, and this point here, then these 3 points are collinear because I can draw a single straight line which cuts through all of them. However, if I take this point here, and this point here, there's no single straight line that can connect through these. So for example, if I try this, then I can't get this one. If I try this, then I can't get that one. And you can try a bunch of them, but no single straight line will ever do this. So to prove whether something is collinear or not, we have to understand one definition for collinearity. So in simple terms, the way that we investigate whether or not 3 points are collinear is by investigating the gradients of these 2 points with respect to each other when you connect them with a line. So here we have the point A and B, and the idea is that we're trying to connect these with a line. Then we have the point B and C, and we're trying to connect these with a line. And the idea is if the gradients of the lines AB, or line segments I should say, AB and BC are the same, then this is one of the prerequisites for it being collinear. The other prerequisite is that B must be a common point between these 2 lines. So this line here has to have B in it, and then that line there also has to have B in it. So let's kind of understand why that's the case. So point 1 is that the gradients of AB and BC must be equal. And we can understand why that is, because if they weren't equal, then the slope of this one would be different from the slope of this one. So you might end up with, let's say, this gradient is maybe, I don't know, 1, let's say. But this gradient here, let's say this was like a steeper one, say this one, and we have like a 3, for example. Then clearly this line here, because it has a different gradient, it could never be hitting C with B as a common point, so that couldn't happen. The second point, as I've already mentioned, is that AB and BC must share a common point B, and we can see again why that's the case, because if they didn't share a common point, if we met the first requirement but not the second one, then we could say, for example, if we have this point and this point, and then this point and this point, although the gradients of these 2 lines are the same thing, they don't share that middle common point. So clearly these lines are not collinear. And again, I've already discussed that the first one has to be true as well, because if the gradient wasn't the same, then you'd shoot off to somewhere else and it would never hit C. It has to be the same gradient as this one with B as a common point. Okay, so let's take an example of this. So here we have the 3 points A, B, and C, and the question is to prove that these points are collinear. So using our definition of collinearity, we have to ensure that the gradient AB and BC are the same number. So let's actually calculate these. So we'll have MAB, and you'll remember from National 5, this is y2 minus y1 over x2 minus x1. So we'll have 3 minus 5, and we'll have 2 minus minus 4. 3 minus 5 is minus 2. 2 minus minus 4, 2 negatives make a positive, so we have 6. And this simplifies to minus 1/3. Similarly, if we calculate the gradient of BC, then this will be 2 minus 3 over 5 minus 2. 2 minus 3 is minus 1, 5 minus 2 is 3, so we again have minus 1/3. So we can see here that the gradients between the line segments AB and BC are the exact same thing, and by definition of calculating that, B must be a common point because you've found the line which starts from A and ends with B, and then you've looked at the line that starts with B and ends with C, so B is a common point in that case. So using the definition of collinearity, we write out the following sentence. Since the gradients of AB, the line AB, and BC are equal with B as a common point. The points A, B, and C are collinear. Okay. So just note that in the exam or in tests or anything like that, this sentence is something that you have to write out. You don't have to write it exactly like this, just as long as you nail the main points. So you have to talk about the gradients being the same, you have to talk about B being a common point, and then you have to say, so therefore these points are collinear, which was the whole point of the question. You were being asked to prove that. In our second example of collinearity, here we have a different scenario. We have the points L82, M2T, and N-1, and we are being told that these points are collinear. So we're not being asked to show whether they are or aren't collinear. We're being told that they are collinear, and we have to find T. So this is a slightly different question, and we have to really think about when 3 points are collinear, what does that actually mean? So we again go back to our definition, that if L, M, and N, or any 3 points are collinear, then the gradients between, in this case it would be L and M and N, must be equal. Alright, so let's see if we can take that to our advantage. So with collinearity, if you're not completely sure what to do, the best bet is to find the gradients of LM then MN. So let's do that. So we have, so for MLM, we will have y2 minus y1, which will be t minus 2 over x2 minus x1, which is 2 minus 8. And this simplifies to t minus 2 over minus 6. And I suppose I could move that minus up and make this 2 minus t, but I guess it doesn't really matter too much. So I'll just leave it like that. And then I have the other one, which is mn, which will be minus 1 minus t over minus 1 minus 2, which will then simplify to minus 1 minus t over minus 3. Okay. And then again, by definition of collinearity, we are being told that this gradient here, MLM, and this gradient here, MN, are equivalent to each other. So we can use that to our advantage by saying, right, well, if this is equivalent to this, so this thing here, this gradient, by definition of collinearity, because again we're told they're collinear, are equal, then so must these things be. These must be equal, because that's just another representation of the gradient. So we can then set up an equation by saying t minus 2 over minus 6 must be equal to minus 1 minus t over minus 3. They must be, by definition of collinearity. And here now we just have a fractional kind of equation that we have to solve. I'm going to solve this by multiplying both sides by minus 3 and then multiplying both sides by minus 6. So that will be moving this minus 3 over here. We'll have minus 3 multiplying the top line. And remember that since there's two terms, we have to write a bracket to denote that it's multiplying the two terms. Then this minus 6 will move over here, and we'll have minus 6 bracket minus 1 minus t. Again, if you're really not sure about this kind of stuff, I recommend going back to some National 5 videos and solving equations. But anyway, so multiplying this out, we're going to have minus 3t plus 6 equals 6 plus 6t. If you multiply these out. And then we have just we've done plenty of these, I hope, so move the algebraic terms on the left, and we'll have, we're subtracting 6t from both sides, that will be minus 9t, and subtract 6 from both sides, And well, if you do 6 minus 6, that's 0. So in the end, you'll get minus 9t equals 0. And then dividing both sides by minus 9, you'll get that t equals 0, because 0 divided by anything, including minus 9, is 0. So this is our answer to the question.